Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss rate expression and rate constant. Last class I have discussed dependence of rate on concentration. Now I will continue. How will you express rate? That is called rate expressions. Then now I am going to discuss rate expression and rate constant. Here first you have to understand this one general reaction you can consider. A plus B, these two are the reactants and product is C and D, capital C and capital D. Okay, and capital A has coefficient small a and B has coefficient small b. Similarly, C has a coefficient C and D has coefficient D. All are small. All coefficients are small. A plus B and it is giving C plus D. This general reaction you have to consider. Okay. Here A, B, C and D, small a, small b, small c and D are the stoichiometric coefficient of reactants and products. Small a and small b, these are the stoichiometric coefficient of reactants, and small c and small d, it is the stoichiometric coefficient of products. Then what will be the rate? What will be the rate of reaction? Then the rate expression for this reaction is rate is you can say directly proportional. Rate is directly proportional to the concentration of A into concentration of B. Concentration of reactant A into concentration of reactant B means molar concentration of A into molar concentration of B, and coefficient will go as power. Coefficient will go as power. But here I will tell you, here you can't write power A and power B. Coefficient is small a for A, capital A, and a small b for capital B, and a small c is for capital C, and a small d is for capital D. But here rate is directly proportional to the molar concentration of A and B, means rate is proportional to molar concentration of A. Power x you write a small x into molar concentration of B power y. You are not writing here a small a and a small b. This is important things. Coefficient is a small a, but you are writing here x, a small x. Power of A is small x, and power of B you are writing here y, small y. You are not writing b. These things you have to understand, where exponents x and y may or may not be equal to the stoichiometric coefficient A and B. May or may not be. Okay, may or may not be equal to the stoichiometric coefficient A and B of the reactants. Above this reaction, this rate expression, what I told you, rate, this you can write that proportionality sign. Now you can convert to equality, and for this purpose you have to multiply by some constant k. Then now proportionality sign will convert to equal sign. Now rate is equal to k into molar concentration of A power x into molar concentration of B power y. Correct? Then rate is equal to, rate you know how to write the rate. Rate is equal to minus dr upon dt. Minus dr upon dt means here R you are writing change in concentration. Okay. Then rate is represented by R, dr minus dr upon dt, because reactant concentration, both reactants concentration will decrease. R means here reactant. Then minus dr upon dt, correct, because you are divided by dt means per unit time, change in concentration per unit time. Then minus dr upon dt is equal to k into molar concentration of A power x into molar concentration of B power y. Okay, I will tell you meaning of x and y. But this equation, this form of equation, what I told you, minus dr upon dt is equal to k into molar concentration of A power x into molar concentration of B power y. This equation is known as differential rate equation. Differential rate equation, where k is proportionality constant called rate constant. This k, proportionality constant, is called rate constant. The equation, this equation I am talking about only this equation. This equation is called rate law or rate expression. Correct? Minus dr upon dt divided by minus dr upon dt equal to k into molar concentration of A power x into molar concentration of B power y. This equation is called actually rate law or rate expression. Okay, this is important. This is called rate law or rate expression. For the equation AA plus BB is equal to CC plus CD. For this reaction, this is the rate law or rate expression. This rate law is the expression in which reaction rate is given in terms of molar concentration. Okay, A and B, molar concentration of A, molar concentration of B, then A and B all are in molar concentration term of reactants, with each terms raised to some power which may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation. Okay, now I am telling you example why, meaning of a small x and a small y I am telling you. Here a small x and a small y, this exponent actually is experimental quantity. Experimental quantity. It does not depend upon the theoretical. A small a, small b, sometimes may be equal, sometimes may not be equal, because x and y, this is the experimental. Its value depend on experiment. Okay, then here this x and y, this value, this exponent value is experimental. Here only I am telling you, if these two power you will add, x and y if you will add, means x plus y, then this is called order of a reaction. Order of a reaction means, suppose if x is equal to 1 and y is equal to also 1. Then x plus y is equal to 1 plus 1, that is equal to 2. Then this is called second order reaction. If suppose x is 2 and y is 1, then 2 plus 1, that is the 3. Then this is called third order reaction. Now suppose x is 0 and y is also 0, then 0 plus 0, 0. That is called zero order reaction. Okay. If suppose x is equal to 1 and y is equal to 0, then total 1 plus 0 is equal to 1. Then overall reaction will be first order reaction. Okay. Then order of reaction it is asked actually in examination. Then this is actually, this value is experimental. Correct? It may vary from the balanced equation. Balanced equation, you have written coefficient A and B. Then it may vary from A and B. Sometimes may be equal, sometimes may not be equal. Okay. Then this I have told about the order of reaction. Only here meaning of x and y I told you. And only here I want to tell you one more term, that is the molecularity. Molecularity of a reaction. Then sometimes what will happen, reaction may take place in one step. Sometimes it may take place in many steps, 3 steps, 4 steps. Then that if suppose it is a reaction is taking place only in one step only, suppose it is taking place, then that is called elemental state. Elemental means main state. Then if only reaction is finishing only in one step, and that step or a state, that is called elemental. elemental, elemental state. And in this reaction, in this step, balanced equation is there. What is the balanced equation for this step? In that step, what is the coefficient? As for example here, a small a plus a small b. You add a plus b. Then that is called molecularity. Molecularity. Suppose a is equal to 1, small a is equal to 1 and small b is equal to 2. Then molecularity will be 1 plus 2, that is equal to 3. If both are 1, 1, a is also 1, b is also 1, then 1 plus 1, molecularity is equal to 2. Like that way, if suppose this only one reaction is of reactant is only one reactant is there and coefficient is 1, then also it is called molecularity is equal to 1 only. Then there is a difference in order of reaction and molecularity. Molecularity is just in a balanced reaction. What is the total number of moles of reactants? Suppose 2 reactants are there, then how many moles are there reacting in a balanced equation? Means coefficient, stoichiometric coefficient, you add it. Just like a plus b. If 3 are there, a plus b plus c, means 3 reactants are there, then a small a plus a small b plus a small d, 3 reactants. Then suppose it is giving 3 product, then leave it. But here a small a plus a small b plus a small c, that is called molecularity. Okay, for the molecularity, what is the number of molecules of reactants in balanced equation? In balanced equation, that total number of molecules is called molecularity. Then this is the theoretical. Molecularity is a theoretical quantity, but order of reaction is experimental. Sometimes order of reaction may be whole number, sometimes in fraction also, sometimes 0 also. This is important, very, very important things I told you. Order of reaction may be 0, may be whole number like 1, 2, 3, sometimes maybe 1.5, 0.5, 2.5, like that way, because it is the experimental quantity. And just you can understand by one example why molecularity and order of reactions are not same. Sometimes may be same, sometimes, but not always. Then I am telling you just a simple example just for understanding purpose. Suppose there is a team of 5 students and they have been assigned a work, but a student has reported from that team only that only 3 were seriously, you can say, engaged in that work. Seriously, only 3% have done. 2 were simply, they were not taking any interest, enjoying here and there. But 3 students were very serious. Then 3 are the actually responsible for that work assigned to that team, not the other 2 who are not doing, only just for counting purpose. Then here situation is same, that molecularity may be more, but order of reaction is telling about that reactant which is responsible for the product. Now suppose A and B both reacted, both concentration is you can say this A and B both are responsible for the product, correct? Then now one molecule you have taken for both, correct? Then now molecularity is 2 and order of reaction is also 2. Experimental value is also telling like that only. They are telling that A is responsible, without A product will be not formed, there will be no formation of product. Or if B is not there, then also there will be no formation of product. Both are required, A and B. Without A and B, there will be no product. Then A and B will be counted in the order, correct? In that also, suppose A may be, product depend more on A, less on B, but they were depending on both, but more dependence was on A and less dependent was on B. Then in that situation, suppose it is 1.5, they depend not in round figure 2 or 1.5, and B 0.5 only 0.5 or 1 only you can tell. Then its order will be 1.5 plus 0.5, 2. Or if you are considering 1, then 1.5 plus 1, 2.5. Then how they are related in the formation of product, that is counted in determination of order of reaction. This I have told you, just I have briefed you. Okay, again I will discuss these 2 terms. Then now by taking some example, I want to tell you the expression. Now I am telling actually this expression definition. Again I am telling you rate law. What is the rate law? Question is asked. Then the rate law is the expression in which reaction rate is given in terms of molar concentration of reactants with each term raised to a some power like x and y, some power which may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation, correct? Now example I am telling you, 2NO plus O2 nitric oxide, 2NO NO is the gas, oxygen is also gas. Then 2NO plus O2, it is giving 2NO2, nitrogen dioxide, okay, or peroxide, nitrogen dioxide. Then now here what you will conclude from this reaction? Then here we can measure the rate of this reaction as a function of initial concentration, either by keeping the concentration of one of the reactants constant and changing the concentration of other reactant, or by changing the concentration of both the reactants. Okay. Then now by example I am telling you, suppose initial concentration of one reactant was 0.30 mole per liter. Suppose 0.30 mole you have taken for reactant 1, and for reactant 2 initial concentration is 0.302, means for NO, nitric oxide, concentration is 0.30 and oxygen concentration is also 0.30, and this is forming NO2. Then suppose now it has formed 0.096 mole per liter. This is the product NO2 formed. Okay, when both concentration were same, 0.30, 0.30, then product was 0.096. Now suppose oxygen you kept constant 0.30 only, and this NO concentration you made it double, from 0.30 you now you made it 0.60, you made it double, but now oxygen concentration is same. Then product form is, it is seen experimentally, then product form is now more 0.384. In the beginning it was 0.096. Now it is a 0.384. It increased. Now again you can see, now keep NO concentration constant, means 0.30 only, and this you increased. Oxygen you increased 0.60, means from 0.30 now increased oxygen concentration 0.60, and NO concentration was only 0.30. Then now product form is with from the first in comparison to the first product. In the beginning it has increased 0.192, but it is less than second one. Second one was 0.384. When NO concentration you made a double, that time it was 0.384, and when oxygen was, that time it was constant. Now you this NO you kept constant 0.30 only, and this you have made a double, oxygen 0.30 became 0.60. Now product increased but less, it increased less, only 0.192 in comparison to when it was a double, NO was double. In that situation it is less, that time it was 0.384. Now suppose you have made a double, suppose you have both you have made double, 0.60, 0.60. Then now product formed is maximum 0.768, 0.768 highest. Then what conclusion you will draw by seeing this value? It is experimental, actually experimental data. Then it is obvious, if you will analyze, if you will see, then you will find, okay, it is obvious after looking at the results that when the concentration of NO is doubled and that of oxygen is kept constant, then the initial rate increases by a factor of 4. 4 times it increased from 0.096 to 0.384, 4 times it increased. Thus, this indicates that the rate depends upon the square of the concentration of NO, 4 times. 4 times is NO power 2, correct? NO power 2 means 4 times it increased, 0.096 and 0.384, it is 4 times. Then it is a factor of 4, increased by a factor of 4 from 0.096 to 0.384 mole per liter per second. This indicates that rate depends upon the square of the concentration of NO. When the concentration of NO is kept constant and concentration of oxygen is doubled, then rate also gets doubled. It becomes doubled, indicating that rate depends on concentration of oxygen to the first order. It became double, 0.096, now it became 0.1 and 0.192. Okay, then it gets double. Then doubled means indicating that rate depends on concentration of oxygen to the first power. Hence the rate equation for this reaction will be rate is equal to K and molar concentration of NO power 2. It was a square, but here it is only one time increased. 4 time means a square of the molar concentration NO. 4, then it is becoming 4 time means it is a square. That's why it is becoming 4. Suppose it was the 2, then it will be 4. Here it is becoming only 2. Then that is called first power, not the square, first power. It became only double. Suppose NO concentration was a 2, then 2 power 2, 4. And here this is oxygen only one time, double, it became the double. Okay, means power, it is not a square, it is not increasing in the square. That is called first power. This was the NO was second power and oxygen is first power. Then rate you can write as a equal to K molar concentration of NO power 2 and oxygen power 1. Okay, in the case of NO power 2 because it is the square, but it is not a square, then that is called first power. Then overall reaction, order of reaction, what you can tell? 2 plus 1, power is nothing, only it means 1 is there, then 2 plus 1, 3. Order of reaction is 3. But by seeing the this balanced equation, 2NO plus O2, it is giving 2NO3. Then reactant, how many molecules are taking part? 2NO plus O2. Then 2 plus 1, oxygen is only 1, nothing is means 1. Then 2 plus 1, 3. Then order of reaction is 3. Order of reaction is 3 and molecularity is also 3. In this case, both are equal. Okay, but always it is not this necessary. Now this, then you can write very easily differential rate. How will you write? Differential form of this rate expression. Now you can write minus dr upon dt. dr means capital R, reactant. Then dr you can say in bracket, right, means molar concentration of R, reactant. Then minus dr upon dt is equal to K NO power 2 and oxygen power nothing is mere, means 1. Okay. Then here we observe that this reaction, this reaction in the rate equation, these things derived from the experiment data. The exponents of the concentration term are same as their stoichiometric coefficient in the balanced equation. Both are same, means order of reaction and molecularity both are same. Okay, now two more example I am telling you. Suppose a chloroform CHCl3 CHCl3 plus Cl2, it gives CCl4, means carbon tetrachloride, plus HCl. Then what will be its rate expression? Rate, then rate is directly proportional, you know, directly proportional of both reactants, means chloroform and chlorine. Then you can write rate is equal to K, molar concentration of chloroform into molar concentration of chlorine. Okay. Then here power, what you will write? Power, it depends on both. Then both term you have to write. Rate is equal to K into molar concentration of this CHCl3, means chloroform, and into molar concentration of chlorine. That is true. But what will be the power? Power, according to the theory, balanced equation, both are 1, 1. No, they have not shown these things, anything. Not shown means 1, 1. But here in rate, what you will write? You can't write 1, 1. That is the molecularity. But here, what is actually experimental, that you have to write. Then by experiment, it has been observed that one you can say molecule of, or 1 mole of chloroform was required, and half mole of chlorine was required in experiment. Hence power will go like that way. For the chloroform, power will be 1, and for the chlorine, power will be half. Correct? Then one you write or not write, it is understood. Then this is the order of reaction for this reaction. 1 plus half means 1.5 or 1.5. 3/2 also you can write. Then order of reaction is 1 plus 0.5 means 1.5 or 1.5 you can tell, or 3/2. All are same. And this another example I am telling you, that now this is there, ethyl state is there, CH3 COO C2H5, ethyl state plus H2O, it is giving acetic acid plus ethyl alcohol. This is the balanced equation. Then here in the first example, in a balanced equation it was one molecule of chloroform and 1 molecule of chlorine. Then in this case molecularity was 2, 1 plus 1, 2, but order of reaction was 1.5. But now in this case, ethyl acetate plus H2O, 1 molecule of ethyl acetate plus H2O, both are nothing, coefficient is there, means 1, 1. Then product is CH3COOH plus C2H5OH, means acetic acid, 1 molecule of acetic acid, 1 molecule of ethyl alcohol. Then here molecularity is again 2. Nothing region means 1 plus 1, 2. But order of reaction now, first you will write expression, then expression you can write rate is equal to K, and after that molar concentration of ethyl alcohol into molar concentration of H2O, correct? Molar concentration of acetic acid, this ethyl acetate, and molar concentration of H2O, both you have to write. But now power, what power you write? Power means what? just telling about the order of reaction. Then now here, what power you write? Molecularity is 2, 1 plus 1, 2. By seeing the balanced equation, you can tell. But order of reaction, you can't tell by seeing the balanced equation. Then what is the power? Then experimentally it is observed that ethyl acetate has 1, power 1, okay, first power, and water has no value, 0, power 0, correct. Then ethyl acetate power will be 1 and H2O power will be 0. Means with respect to ethyl acetate, it is a first order, and with respect to H2O, it is a 0 order. Okay. Then first reactant ethyl acetate, with respect to the first reactant means ethyl acetate, it is the first order, but with respect to water and second reactant, it is a 0 order. Hence, overall order will be 1 plus 0. That is the one only first order reaction. First order reaction. This is the example of first order reaction. Correct? Then these two reaction, what I told you, is very, very important for understanding. Okay. In these reactions, the exponents of the concentration terms are not the same as their stoichiometric coefficient. Thus, we can say that this thing, the rate law for any reaction, by seeing this, we can tell rate law for any reaction cannot be predicted by merely looking at the balanced chemical equation, that is the theoretically, but must be determined experimentally. Correct? Power you can't know by seeing the theoretical, that is the molecularity you can tell. For this you can just only you can know by experimentally, and it is determined experimentally. Okay. Then this I have told you about the this things, rate law. Now actually already I given the concept of order and molecularity, but definition I want to tell you. Okay, same reaction you keep in mind that rate is equal to K molar into molar concentration of A, means in big bracket A you can write power X, and into molar concentration of B power Y. Okay, this is the rate law for the expression AA plus BB is equal to CC plus DD for this reaction. Then now you can define the order of a reaction. X and Y indicate how sensitive the rate is to the change in concentration of A and B. Already I have explained by giving the value 0.30 and 0.60. Okay, sometimes reaction depends more on one reactant and less on other reactant. Then this sum of these exponent x plus y gives the overall order of a reaction, where x and y represent the order with respect to the reactants A and B respectively. Hence, you can define order of reaction. How? Then like that way you can define that it is the sum of powers of the concentration. The sum of the powers of the concentration of the reactant in the rate law expression is called the order of that chemical reaction. Again you understand, Order of reaction is the sum of powers of the concentration of reactants in the rate law expression. Okay, this is called the order of that reaction. Correct. Now this already I told you, order of a reaction can be 0, 1, 2, 3, and even it will be in a fraction also. Okay, a 0 order reaction means that the rate of reaction is independent of concentration of reactant. 0 order means what? It is not depending upon concentration of reactants. 0 means what? Not depending on reactants. Question is asked. Okay, the rate of reaction is independent of the concentration of reaction for the 0 order. A 0 order reaction means this order of reaction is 0. Okay, it means does not depend upon the concentration of the reactant. It is independent of. Reaction is independent of concentration of reactants. Then now one numericals I am telling you, I think easily you can solve it. Question I am reading, which is very small. It is fit for the main IIT main or medical. This type of question may be asked. It is easy. Calculate the overall order of a reaction which has the rate expression. They have given 2 rate expression they have given. Then rate expression is there. You have to calculate the overall order of reaction. Means x plus y you have to consider. Then first expression is rate is equal to K, molar concentration of A, power is half, and into molar concentration of B, power is 3/2. Then A has power half and B has 3/2. Then see what will be the order of reaction. Quickly you can tell. Means 3/2 means 1 and half. 1 and half. Then A is half and B is 1 and half. Then total half plus 3/2 or 1 and half, that is equal to 2. Means it is a second order reaction. Means x plus y is equal to 1/2 plus 3/2, that is equal to 2. That is called second order reaction. Second question is that rate they have given. Rate is equal to K, molar concentration of A, power 3/2, and B power -1. Then how we will calculate? Now we have to add both. 3/2 plus in bracket -1 you write. Then 3/2 minus 1 means 3/2 means 1 and half. 1 and half minus 1, that is the half only. Then x plus y you have to write. Then x is equal to 3/2 plus and y is equal to -1. In bracket -1 you write. Then plus minus. Then 3/2 minus 1 means 1 and half minus 1, that is the half only. Hence reaction is this order of reaction is half. Order of reaction is half, means half order reaction. Correct? And then this I have told you about the order of reaction. Okay. Now I will discuss, and that is the distance rate of. Actually, I want to tell this rate unit. Last class I discussed the unit, but here one general rule is there. General rule is there to know the unit of this things. To know the unit of first order, 0 order reaction, second order also you can know by following the formula. One formula is there. Then by knowing that formula, you can easily know the unit Okay, then here I am telling you unit of rate constant. Okay, now this one example first I will tell, then you can understand. Actually, elementary reaction, you should know about the elementary reaction. Already I have told you. Okay, again I am briefing you. Then I will come for that general formula for unit. A balanced chemical equation never gives us a true picture of you can say how a reaction takes place, since rarely a reaction gets completed in one step. Very less reaction you can say completed in one step. The reaction taking place in one step are called elementary reaction. Correct? The reaction taking place in one step, any reactions, the reactions taking place in one step is called elementary reaction. When a sequence of elementary reactions is there, that is called mechanism. Okay, if many steps are there, when a sequence of elementary reactions is there, then gives us the products. After the some means directly will not get in one step, you will not get the product. And there will be sequence. When a sequence of elementary reactions gives us the product, the reactions are called complex reaction. What is a complex reaction? When you are getting the product after several steps. After several steps means sequence of elementary reaction. Then this sequence of elementary reactions are called mechanism. It's called mechanism. Sometimes maybe 2 steps, sometimes 3 steps, sometimes 4 steps. And these sequence are called mechanism, because after passing through these 4 steps only you will get the main product. And in the middle, that is called intermediate steps. Initial step, intermediate steps, maybe 2-3 steps, all are intermediates, because it will be for short period, and finally it will give a product that will be permanent. Then these type of reaction which takes place in many steps, then that is called a complex reaction. Complex means difficult. Complex reactions, and these steps are called mechanism. Okay, example I am telling you that this oxidation of ethane to CO2 and H2O passes through a series of intermediate steps in which alcohol, aldehyde and acid are formed. 3 products are formed. CO2, finally this ethane, C2H6, finally it will give CO2 after oxidation. Correct? This after oxidation, ethane gives to carbon dioxide. That is the final result, carbon dioxide. But in the middle you will find aldehyde, you will find alcohol, you will find acid. 3 products you will find. That will be for short period, that is called intermediates. And then you will get CO2. Correct? It gives oxidation of ethane, it gives actually carbon dioxide plus H2O. But these are the final product. But before getting these 2 products, you have to cross through 3 intermediate. That is the alcohol, aldehyde and acid. Then finally you will get CO2 and H2O. Just like in a simple way, for understanding purpose, you have to go your home. You get to the market, from the market you wanted to go to your home, or from home to market. Then 3 you can say stoppage are there. You are going by bus, suppose. Then 3 stoppage are there. Then you are reaching the market. Correct? Then like that type of steps are there. Then starting is your home and final is your market, or from market to your home. In the middle 3 steps are there, 3 stoppages are there. Then like that type of situations are there. And these steps are called actually mechanism. Sequences are called several steps are called mechanism. Okay. Then now I have told you about the complex, this type of reactions which takes place in sequences, that is called, or in several steps, that type of reaction is called complex reaction. And only one step we are getting the product, that is called elementary reaction. An elementary reaction is different, and this complex reactions are different. But one thing only here I want to tell you, okay, that slowest step, suppose 3 steps are there, then you are getting final step, final product. Then out of these 3 steps, which is the slowest step? Slowest step, that is the rate determining step. This is a very important thing I told you. Okay, out of 3 steps, which are the rate determining steps? Then slowest step is the rate determining step. Just one example I will tell you. Suppose running race is going on, running race, and suppose they have to judge which one is the first, which one is the last. Okay, so 4 students are there. 4 students taken part in a running race, and you have to find out. Suppose all are, you can say, this all participation has importance. All participant has importance. Their participation is important. You have to give grading. Who is the first, who is the second, who is the third, who is the fourth. You have to give this grading. Then what? Suppose someone has came very fast. Okay, only in 30 seconds he reached. Other reached in 15 seconds. First reached suppose 45 seconds. Suppose second one 45 seconds. Third one 60 seconds. Means 1 minute. And last he was a 50%. He reached. He has taken 1 minute 5 second time. 1 minute 5 second time. Then now, how can you take decision by seeing only first, second, third? You have to make a grading. Then up to the last you have to wait. You have to see all 4 this performance part. You have participants capacity you have to judge. Only then you can take any decision, because all 4 are important. Or other way you can understand. So suppose production is going on, motorcycle production is going on. Then suppose 100 engineers are working there, or 100 persons are there to make 100 parts. Suppose all parts are necessary. All parts are necessary. Then all 99%, 99% they are making only in 1 day 1 part. One person has taken 3 days time. 3 days time. 99 parts are ready only in 1 day. Then motorcycle can't run without that 1 part. 1 part has not ready. Then motorcycle is not ready until 100 parts are ready. If all 100 parts are ready, then only you can tell now motorcycle is ready. You can tell in 1 day 1 production. 1 day 1 motorcycle is produced, manufactured, 1 motorcycle per day. But now you can't tell. One person has taken 3 days time. Other have finished only in 1 day. And that person was making engine of the motorcycle. Then how can you neglect? You can't neglect. Correct? Even who is making a brake, that also you can't neglect. All parts are important. If tire is not there, if tube is not there, if handle is not there, and it means whatever part is required, all must be ready. Only then you can announce that, okay, now one motorcycle is fully ready. Then here, same situation as there in a reaction. Because I told you that when reaction will take place, suppose reactant A and reactant B, both are taking part, then reactant A, suppose it is a glucose C6H12O6, then see how many atoms are there in one molecule, plus H2O, both are reacting, correct? Then that all bonds of glucose or sucrose, whatever be, sucrose is C12H22O11, then all bonds should break. First it will break. H2O bond will also break. Correct? Or any reaction is considered like that. Both reactants, all bonds should break. And then reaction will take place. Then new bond will form. New product will form means a new bond will form. Then breaking the bond. Suppose in breaking the bond, 2 steps are required. And with the reaction, 1 more steps are required or 2 steps are required. Total 5. Correct? Then breaking of the bond, breaking of bonds of reactant A, breaking of bond of reactant B, and then a reaction will take place. First breaking, and then they can form short intermediate, and then they can make permanent product. Then all steps are important. You can't neglect any step. That's why slowest step, what is the time taken for the slowest step, that determines the rate of reaction. Correct? Just like I give an example. In competition of four person, you have to see the performance of 4. Only you can announce the result. And like that way, for the reaction, all steps are important. Then total how much time it will take for the reaction, that depends upon the slowest step of the reaction. Okay. Then this I told you, slowest step is the rate determining step. And in elementary step, what is the balanced equation? In that, how many reactants are taking part? That number is called molecularity. For molecularity in a complex reaction, which reaction is the elementary important, and what is the balanced equation for that step? Their total number of reactants taking part in a elemental reaction, main reaction, in a balanced equation, that is called molecularity in a complex reaction. Otherwise, only in one step reaction is taking place, then no doubt. What is the number of reactants taking part in a reaction? That is the molecularity. Then this I have told you about the distance rate determining step. Order of reaction I told you, and rate determining step also I told you. Now I will brief it about the general reaction and unit, about the unit. Okay, how will you write the unit? Because many questions are asked on this. Then now again you consider same reaction, AA plus BB, it is giving CC plus DD. Then for this reaction, rate is equal to K, molar concentration of power A, and molar concentration of B power X and Y you can consider, K into molar concentration of A power X into molar concentration of B power Y. Then here X plus Y is equal to N. Actually, order of reaction is indicated by N. Order of reaction is indicated by N, small n. Then X plus Y is equal to N, and N is the order of the reaction. Then by this reaction, rate is equal to K and A power X into B power Y. Then you want to know about the K. What is the K? Cell, that is a rate constant. K is the rate constant. Then K is equal to rate divided by molar concentration of A power X into molar concentration of B power Y. Very simple way. Rate is equal to K. K into A into B. Then K is equal to what? Rate divided by A into B. A power has X, B power has Y. Then this K expression is the main things. Then rate, how will you write? Rate you will write concentration divided by time. Rate is equal to what? Concentration per unit time. Means concentration divided by time. Rate you have written, and rate you have written. Now you are elaborating. The rate value you have written concentration divided by time. Now rate divided by concentration of A into concentration of A power X into B power Y. That value also you have to write. Then just if you will expand, then you rate you have to write concentration divided by time. After that, this AB you have written, down AB you have written, AB upon 1 you can write and reverse it. You are simplifying, you reverse it. 1 will go upside, AB will come down. Means concentration of A and B. A is also concentration, B is also molar concentration. Both are molar concentration. Then only power you have to add. Both are concentration term only. A is molar concentration, B is molar concentration. Hence only one time you write concentration. But power you have to write X plus Y. X plus Y, that is equal to N, a small n, order of reaction. Correct? For the A also molar, A is also molar concentration. B is also molar concentration. A has X power and B has Y power. Hence only one time molar concentration write, and power you write X plus Y, means N, that is equal to N, a small n. That is called order of reaction. Then now this is actually formula. Suppose A is equal to B, only in that situation, because both are molar concentration. That's why power you have added. You have written X plus Y, or finally you can write a small n, concentration power N. Then now you got the formula concentration divided by time into 1 upon concentration power N. This always you keep in mind. If you are in confusion to how to write, how to know the this expression unit, then this way easily you can remember, you can calculate also. Then now concentration by time, then concentration time, concentration time power minus 1. Okay, and फिर concentration 1 upon concentration is there. Correct? Then that also concentration minus n also you can write, if in one line you want to write. Then here by following this formula, this relation, you can calculate for all 0 order, first order, second order. Then here for 0 order, what will be the this things unit? Then concentration, you know, concentration you can write mole per liter divided by time. Then time again it will go up, time minus 1. Then you can write mole per liter per second. Mole per liter per second. Okay. because only these two terms is required. Rate divided by concentration. Then here concentration is a mole per liter and time is in second, then per second, hence a zero order reaction, its unit will be mole per liter per second. Okay, because here concentration is mole per liter divided by time into 1 upon concentration power n, then here n is equal to 0, 0 order, and 0 order means what? Power 0 means 1. Then for the second term 1 upon concentration power n, that became 1. Then only concentration upon time is remaining. Hence for the concentration mole per liter and time is in second, then per second. Hence for 0 order unit will be mole per liter per second. And for the first order, now you can see concentration divided by time into 1 upon concentration power n is there, but here n is equal to 1. Then both concentration term will cancel. Concentration divided by time into 1 upon concentration power n was there, but n is equal to 1. Then both concentration term will be cancelled. 1 upon time, then time is in second, then its unit will be second minus 1 means per second. This is the first order reaction. For the second order reaction, same expression, you see, second order. Now n is equal to 2. N is equal to 2. Okay. Then here n is equal to 2, n is equal to 2 means power is 2. Then you can write concentration into concentration 2 times. Then 1 concentration will cancelled out. Then what will remain? Time will be down 1 upon time into concentration. In a denominator 2 terms will be there. 1 upon time into concentration, because 1 concentration cancelled. Then now easily you can write 1 upon time means a second inverse, and 1 upon concentration means concentration inverse. Then concentration is equal to mole per liter. Then now both sign will change, mole per liter, then mole per liter constant power minus 1 is there, then mole will become minus, and per liter was there minus 1, L is equal to minus 1, that will come plus L, means sign will change. Mole generally will be without power, mole per liter, but now reverse way it became mole minus 1, liter became plus 1, that is only L you can write. Then mole minus 1 L, and time is per second only in all cases. Then mole inverse means mole minus 1 L S minus 1. This is the for second order unit. Then this I have discussed how to calculate or how to know the order of reaction, either in second, minute or hour, whatever be, as per the question. Then now I am stopping only here. Again next class I will continue. Thank you.